Hello everyone, our next concept is reciprocity theorem. Reciprocity theorem said that if a linear passive bilateral network contains single source, then the ratio of response to the excitation is constant even though the source is interchanged from input terminals to output terminals. The meaning of statement is, for suppose there is a linear passive bilateral network only up to here. If it is a linear passive bilateral network. Linear passive bilateral means the network contains resistor, inductor, capacitor and ideal transformer as the elements. If these elements are containing by any network, that network is called linear passive bilateral network. If this linear passive bilateral network contains single source, then response to the excitation, response means output. Here, for suppose this is response is current I1. For suppose if excitation means input, response to the excitation, output by input is constant even though we interchange the source from input terminal to output terminal. If we interchange the source means, let us take it is V2 and this response is I2. Due to V2 this is I2 and this must be constant. That is, here this is response, this is input now. So I2 by V2, they should be constant. Limitations are, this theorem is only applicable for linear passive bilateral networks only. And second limitation is, presence of dependent source in a network make it an active and hence this theorem is not applicable. So-called non-reciprocal network. For suppose, if this network contains any dependent sources, don't take this excitation and this response, only consider this linear passive bilateral network. Mid of this linear passive bilateral network, if this network contains dependent sources, any dependent source, then this theorem is not applicable. Such type of networks are called non-reciprocal network. And third limitation is, if I by V equal to mho means inverse of ohms, and V by I is equal to ohm, then this theorem is applicable. That means the ratio of excitation to response must have some units. You need to take, if input is voltage, output must be current. If input is current, output must be voltage. Then only this theorem is applicable. If I by I is equal to no units and V by V equal to no units, then this theorem is not applicable. If excitation is current, then output must not be a current. It should be a voltage. If excitation is voltage, output must be current. It should not voltage. For suppose I am considering one example. This is linear passive bilateral network because all elements are resistors. Okay, these resistors are linear elements, passive elements, bilateral elements. Here I am giving input, let it be 20 volts. Now find the response. Okay, I am shorting these two terminals. What is current I? These two resistors are connected in parallel. Okay, these two resistors are connected in parallel. So the equivalent is, if two equal resistors are connected in parallel, equivalent is resistance by 2. So this is 2 ohms. Again, this parallel combination and this 3 ohm are in series. So 3 plus 2, 5. So now what is the total current here? I total is equal to 20 by 5, 4 amps. Same current is flowing from here to here. So this is 4 amps. If two resistors are connected in parallel with equal values, current is divided equally. So it is 2 amperes. Now, so what is I value? 2 amperes. Now response to excitation is I by V is equal to 2 by 20, 0.1. Coming to here, now I am interchanging this voltage from input to output. So this is 20 volts. Now find the response, let it be I1. First of all, find the equivalent resistance from here. These two resistors are in parallel and this resultant is connected to this resistor in series. So what is R equivalent? R equivalent is equal to 4 plus, these two are in parallel, 3 into 4 by 3 plus 4. So R equivalent is equal to 40 by 7 ohms. Now what is total current here I total is equal to 20 by 40 by 7 V by R equivalent. This is 7. So current is 2 times 7 by 2 amperes. Now determine I1 by current division rule. Here current is 7 by 2 amps. By current division rule, what is I1? I1 is equal to opposite resistance 4 by total resistance 3 plus 4 into total current. Okay, this is total current into 7 by 2. So you will get I1 is equal to 2 amps. Now what is response to excitation? I1 by V is equal to 2 by 20, 0.1. So in both the cases we got same answer. That is response to excitation must be constant. Consider one more example. This is two resistors are connected in parallel. This is linear passive bilateral network. Here no active elements in this network, so it is linear passive bilateral network. Now I am exciting this with one current source, that is 9 amps. Now find the voltage across these two terminals. Let it be V1. So what is the current flowing through the 6 amps? The voltage across three elements is same because all three are in parallel. Now find the current flowing through 6 ohm resistor. Let it be I1. By current division rule, what is I1? Opposite resistance by total resistance into total current. You will get 3 amps. Now what is V1? V1 is equal to IR. So here I1 into R. I1 is 3. R is 6. It is 18 volts. So what is the response to excitation? V1 by current I. 18 by 9, that equal to 2. Coming to this circuit, I am interchanging this source from input to the output terminal. Then source become like this. This is 9 amps. Now find the voltage across these two terminals. So this is, let it be current I2. By current division rule, what is I2? I2 is equal to opposite resistance by total resistance into total current. So I2 is 6 amps. Now find the V2, voltage across 3 ohm resistor. V2 is equal to I2 into R, 6 into 3. V2 is equal to 18. Now find the response to excitation. Response means output. Output is 18. Excitation is input 9 amps. So we will get 2. So in both the cases we got same answer. That is response to excitation is constant. In the next video we will discuss some more problems on this concept. Thank you for watching.